There are 3 lecture videos in Physics 2212 this week. All of them relate to electrical conductors and insulators. The lecture videos began by identifying 2 electrical classes of matter, insulators and conductors. They defined insulators as having no mobile charges, while they defined conductors as matter that does have mobile charges. Whether a material is a conductor or an insulator is dependent on how the protons and electrons are arranged at a microscopic level. Next, the video went on to introduce the conservation of charge. This states that charges cannot be created nor destroyed. So, in order for an object to be changed in their charge, there must be a transfer of charges to or from that object from an outside or to an outside source. The video then went on to give an example of how electrical conductors or insulators show conservation of charge by showing tape as it is removed from one another. If the tape showed an attraction between each other, they both must have a non-zero net charge. Lecture video 2 went on to get more specific with the polarization in macroscopic samples of insulators and conductors. The video began by reviewing what polarization and dipoles mean. Dipoles can be defined as 2 particles opposite in sign with the same charge Q that are separated by S. Polarization, as previously known from last week's lectures, is a shift towards the electric field if positive and away from the electric field if negative. If you are observing the polarization in insulators, if an external field has been applied, the sample has a steady, non-zero dipole moment P in the same direction as the external field. It's important to note that the electric field net will not equal the external electric field. When observing polarization in conductors, if an external field is applied, the positive ions will move in a direction of the external field, while the negative ions will move in a direction opposite to that of the external field. Lastly, the video touches on how in equilibrium, the net E field in a conductor will equal 0, but this is only if it is in equilibrium. This is due to superposition and the fact that conductors don't block the field. The 3rd lecture video gave more examples dealing with conductors and insulators. There were many key things to take away from these lectures. Although we previously had learned the definitions of polarization and dipoles, and I had been previously exposed to the definition of insulator and conductor, I got to learn about the conservation of charge and more differences in polarization for conductors versus insulators. The hardest topic for me was dealing with superposition and how that ensured that in equilibrium the net E field in a conductor would equal 0. After looking up superposition and learning that it was the action of placing one thing on or above one another, the fact that the net E field would only equal 0 if the conductor was in equilibrium made a lot more sense. Lastly, the topic that sparked my curiosity the most was how positive versus negative ions reacted in relation to the E field.